Welcome back. In this video we'll continue from where we ended last. Sorry. And we will start with we will continue with this ferrooxidants. Now these kind of questions normally require you to pay attention. You can take 2 minutes. You can take 2 minutes, just read the question and understand. They really require you to evaluate the data. Okay, and one of the things that the A-level examiners require you to know is to evaluate the data. So you can pause here, take even 5 minutes if you want. Okay, and just find out what is the answer here. I mean, you just describe the results in table 2.2. Forget about the role of natural selection. Forget. Just describe this. So you can pause now. Okay, hopefully you paused and you got the answer. Now let's see over here. We have 2 strains of the bacterium, right, in the presence and absence of arsenic ions, and we are told that arsenic resistant strains of A ferrooxidants have been found in some mines. So if we check over here, the arsenic ions when they are absent and when they are present, it doesn't make any difference, is there? It's just difference of 1. So we can count this as no difference. So actually all these strains, both the strains are resistant. So that's the first thing we have to understand. Okay, if you didn't get that, then oh, I'm sorry, but then this was the first thing you should be noting. Okay, and then the other thing you see is that this one have only 16 to 15. I mean, they're very little. Oxidation rate is very low, while this oxidation rate is very high. Why is that so? Because these are more active. So that's the second thing. You have to say that arsenic ions, when they are when strain 2, for strain 2, they are very active compared to strain 1. Okay, so those 2 points will clear the point with this. I mean, we describe the result in table 2.2, right? And then you can quote some values. And then the second thing is role of natural selection in the evolution of arsenic resistant bacteria. So if you want to explain natural selection, you can say that selection pressure occurred. Okay, evolution of arsenic. How does arsenic resistant bacteria get produced? So there was a selection pressure. Okay, mutation occurred. So the first thing you should mention here is mutation. Okay, mutation. I guess I'm writing very slow. Let me just use the text over there. So first mutation occurred. So different alleles. Okay, different alleles, right? Then what happened is mutation, then selection pressure, right? And different favorable resistant traits selected for. Okay, then what happened? So we get 2 different species. We get resistance species. As simple as that. Okay, you can explain this in 4 processes, and that's what the marking scheme said. There is mutation, the resistant bacteria survive, resistant allele passed on, frequency of allele increases. Okay, you should mention the term allele. They emphasize over here the term allele, but then it's the same thing. There is selective pressure mutation occurs, so only the resistant bacteria survive, others all go away. You can keep it either way you want, okay? You can have selection pressure before then mutation, or vice versa. It's okay, and that's what I did here. I started with mutation, then there is a selection pressure. So selection pressure obviously will select for the best traits. So hopefully that was clear, and I wish you good luck. We'll get into the next video explaining the next question over here.